All right, so yes, I can understand that programming assignments make you want to cry at times. Let me get my screen share set up and we'll take a look at what we got going on today. Sorry for the delay. All right. Make sure I got everybody here. Yeah, let's take a look. There, it's up now. I have to go in and publish this every time, and I forget sometimes. But it should be available now. I'll probably pull it in here as well, like I've done for these. But yeah, you can go back and watch it. And what we're going to do today is we're going to get jumping in with Unity, going over some basics on how to get started. Just some real basic stuff. All of you at this point should have Unity downloaded. You should be exploring the environment, getting used to it, starting on your project, all that good stuff. We're kind of in the get into the meaty part of the semester. And so you want to make sure that you're really working on your assignments, not your assignments, your game, be working on your game. So let's open this up. So this might be a little outdated, but these are 3 good YouTube videos, and there's not much to get into today. I am going to go over some stuff in Unity because I want to make sure that this stuff is relevant and updated, because you guys know with technologies and software, all of it gets updated constantly. And so my goal for today is so that you guys are a little bit familiar with Unity in general. Okay, so I will probably start a new project. Let's go and pull up. You guys still see my screen? Yeah. Okay. Create a new project. Okay, and everybody's going to be working in 3D. 3D Core is where you want to work. You can download these packages. Excuse me, for learning, if you want to kind of get into those. If you really are making a game that is similar to one of these and you want to use those as a starting point, that is fine. Just keep in mind the 70-30 rule, which is 70% of the content has to be stuff that you created. Okay. Now, difference between these two, HDRP and URP. For the purposes of this class, it doesn't matter. Those are rendering pipelines. So the first is high definition rendering pipeline. Whenever I start talking, I start yawning. You'll have to forgive me. And the URP is universal render pipeline. The difference between the two refers to the lighting and the overall visual quality of the game. HDRP is the highest quality. If you, and again, none of these really matter for the scope of what you guys are doing in this class, but URP is what I would suggest you doing. HDRP is for like high-end PC, ultra realistic games. URP is for console, mobile, and you can even do PC games like Access Football uses URP, the Universal Render Pipeline. It's just not, they don't have quite as many tools that you're going to get in the high definition render pipeline, but you can't use HDRP on mobile. You can't use it. You're certainly not going to use it on a Switch or any of the slower consoles. And so you kind of want to keep that in mind. I would suggest do URP, or you can just start with the core. It doesn't honestly matter for what we're doing in this class. Excuse me. Okay. All right, while this pulls up, Do you guys have any questions for me about anything you've encountered so far with your game design document, getting started with your project in Unity? Let me look at this. So if we go back to modules, I did want to look at this really quick. Your game design document is due. Look at assignments. So this, what makes a good game, that's your next homework assignment. That's due February 3rd. So next Friday, not this Friday, but next Friday, your game design document is due. And then the Friday after that, no, I said that backwards. I'm sorry. Next Friday, your second homework assignment is due. What makes a good game? The Friday after that, your game design document is due. All right. And so we will cover this, what makes a good game. We will cover this next Tuesday. All right, so we're gonna get into a sample Unity project today, explore the UI, kind of make sure you guys are good, at least in terms of the basics. Thursday, we're going to go over representing this 3D environment, and then we'll cover this next Tuesday. All right, and then the homework assignment related to this will be due Friday. Everybody good with that? Questions on that? Cool. Okay. All right, so back and let's jump into this. So here is Unity. That's our sample project, and let's explore the UI a little bit. So a couple things. I often get the question, what Unity version should I use? Does it matter? No. It doesn't matter what Unity version you use. I'm on 2020.3, but this is only because that's the LTS version I've got. If you open up Unity Hub, which I suggest you should use, go to installs, and this is where you can get different ones. So these official releases, these are old ones. Where do you add new ones? There, install editor. Oh, there it is. They've changed this since I've seen it last. All right, so go install editor, and you want to go to official releases. I suggest picking one that has this LTS next to it. So if you look, it looks like there's 3 versions. There's the 2020 version, 2021, and the 2022 version. The LTS stands for long-term support. These are versions that they plan on supporting and bug fixing long-term. Not every version has that. And so you want to make sure that when you pick has that. I would suggest if you're just starting out, go ahead and download this 2021 version. The reason I'm on an older version is because, excuse me, when you submit to certain consoles like Xbox and PlayStation, your Unity version has to match up with a particular SDK version. And so when they write SDK versions, it has to match a particular Unity version. And so that's why I'm behind, because it's got to match the SDK version I have. So I would grab this new one, but it doesn't honestly matter. It's small UI changes for what you'll see here. And there are some more complex features, but for getting started with Unity, there's not going to be a whole lot of difference. That is for Unity version. As far as your screen layout, there are lots of different ways to do this. This is how I like to do it. Some people like to have it split like this. Some people like to have this split. You can do lots of different things. But let's talk about what these different components are and how they're used. Okay, so we've got a handful of different tabs here: scene, game, hierarchy, project, inspector, and lighting. All right, so that's kind of the main ones. There are others that you can get to by going under the Windows tab at the top, but let's talk about these. So your scene is this gives you a view of your game in a free form camera view. Like you can move around the scene, you can look at all kind of different stuff. And so like if I want to add objects to the game, I can move around and view them as I want in the scene. This is a no restrictions view of your game and its environment. The game view is what the user will see when they're playing the game. This is seeing the game through the camera. Okay. Let's hop over here to hierarchy. Hierarchy is everything that exists within your particular scene. Unity divides up sections of a game into different scenes. All right, so oftentimes the way it's done is you have a scene for like the initial loading, or like some people call it a splash screen, where it shows like the title of a company and all of like the initial startup stuff. That is typically a scene. And then you typically have like a main menu as a separate scene, and that's where like you select your game mode, you do all the stuff you need to do, and then there's a game scene where you actually play the game. So you typically have 3 scenes, and you can have multiple, you can have a lot more than that. If you're designing a platformer or something like that with multiple levels, each level is typically a separate scene, and so that's how it's kind of separated. Let me give you an actual example. Here is this is actually football. I have a splash screen which just has a I'll go to this, I'll show you. Why is there a city here? There should not be a city in the splash screen. This is funny. Hold on. I don't know what's happening right now. Thank you. I don't know what city this is. This is a real city. Unity does this kind of stuff sometimes. First person who can tell me what city this is gets an automatic 100 on their midterm. Yeah. Is it Detroit? And it's not Detroit, I know that. It could be Chicago. I'm gonna go to lighting. Ah, I see why. No, it was Arizona. It was Arizona. Good try though. All right. So, anyways, what happens in the splash screen? No, Phoenix. I'm sorry. It's yeah, Phoenix. All right. So, what happens during the splash screen is a lot of initialization. You guys are fine. I'm reading chat. That's why I stopped. Yep. You get 100 on your midterm. You got it. All right. So a lot of startup stuff starts here on in the splash screen. Sorry, I can't read and talk at the same time. I can't do most things at the same time. So, for example, like all of the startup functions for creating the variables that you need, creating the objects that you need, but don't have any display to them, those get created during the splash screen. And then the splash screen transitions, excuse me, to the title screen. Let's see. Right. So the title screen is where you do everything from, well, I'll just run it and show you. This is where you do everything from picking your teams to setting up what game you want to do and all kind of different stuff. But the actual gameplay doesn't occur here. So this is the equivalent of, if we're looking at Mario, where you're picking your level, you're loading your save slot, or the save slots in Mario. But the actual gameplay where you're jumping around and stuff doesn't happen. Okay, so you can go through, pick your teams, do all that sort of stuff. This all happens in the title screen. Okay, and there's different ways to set this up. This is just one example. This is where you pick you can go to franchise and load your season stats and all that sort of stuff. But this happens all in the title screen. Okay. And I'm running through this to give you guys an idea of how you'll want to set up your games. Now, the actual gameplay takes place in what I call the game scene. And the game scene is where the actual football match takes place. And I do some more advanced stuff here where I combine scenes at runtime. And so like what this game scene has is it has the football players that actually need to be used in the match. So these are the players that stand on the sideline. You see the refs, you can see the uprights, and these are the players that will actually play in the match. This gets combined with the actual stadiums dynamically at runtime. So once the user picks, okay, I want to play in this stadium, the stadium gets combined with this data because I didn't want to, there was no need to have it in multiple places. Okay. So for example, this is the Arizona Stadium. See that building? And so this scene combined with the players or the game scene gets grouped together while a game is running to do it. And so I have separate scenes set up for each stadium in the game, and then they get combined together. Okay. So here is Atlanta's stadium. And again, it's all, these are just different setups. Okay. Questions? We'll look at one more. And we do some, basically, like if you look, see how the city didn't change? It's the same city. Yes, the ad for the Chosen's in the finished game. What you're seeing now is the live game. This is like if I do a build now, it will be for the live game. But we have it set up to where if you go under lighting environment, you can swap in any of the cities that you want. So this, what city is this? Buffalo. So we drop in Buffalo. This is Buffalo Stadium, or this is Buffalo City. Or if we want to make it nighttime at Buffalo, we drop in the Buffalo nighttime. Or if it's cloudy, like if it's raining, we need to make it cloudy, we just drop it in there. And we'll talk later about lighting and that sort of thing. But that's how that works. Okay, big questions on scenes right now, on what a scene is and how they separate and categorize different parts of your game. Any questions?
How do you like transition or go between screens essentially? Like how would you get from the title screen to the game screen?
Well, have a fancy script called a loading screen manager that runs, and we can take a look at this So essentially, if I go to close out all these scripts, I go to scenes and then we go to title screen. No, we were in the title screen. Hold on. I meant to go to splash screen. Okay, so here is our splash screen. And what happens is, where is, hang on, I'm reading chat. All right, a lot of questions. Let me answer Susie's question first. So as a general rule, when you want to know how to do something, Google is your best friend. It's going to find you all the information you need. I Google stuff all the time. As long as I've been doing this, I still Google stuff. Just typically start your search with Unity and then type it. So you'll do Unity, how to switch between scenes, or something like that. And this, I have a script set up like this, and here's how this works. And we can take a look at this code. Can you all see this okay? All right, so I have a loading manager or loading screen manager, and the loading screen is responsible for popping up, showing a progress bar when we're transitioning from one scene to another. And so when this starts, the first thing that we're going to hit is we're going to hit the start function. Unity has several built-in functions. Start is one of them. Start gets called when the game object that this script is attached to first gets started. Yeah. You won't get much of it. So the first thing that happens, and we're getting a little bit ahead of ourselves, because a lot of this is going to be difficult, because we haven't covered it. But essentially, this is how you switch scenes. And I'm doing it async, and so it's a little bit differently. And this is a little bit more advanced than what you guys will need to do. But Susie, we'll come back to that later. I will say just Google how to switch them, because, and not that I don't want to answer your question, but in order to answer your question properly, I've got to cover a lot of other material first.
That's fine. I get it.
There
Also,
are easy ways to do it.
Someone wrote in the chat that, can you show the title again? And are you expecting a title screen or a product? Not me, it was Nicholas Kohler.
Gotcha. Yeah, I'll show the title screen again. Yes, you need a title screen for your game. You need some way to get started with the game. So when the game loads up, it's fine if it goes straight to the title screen and that's what loads. That's totally fine. But there needs to be some sort of, play game button, maybe an instructions button, that sort of thing. It doesn't need to be complex or fancy, but it needs to have some options for the user to interact with the game. All right, you wanted me to show the title screen again. It's getting into play mode. All right, what specifically did you want to see?
Well, I just wanted to see what it looked like.
Oh, okay. This is what it looks like.
Thanks.
And I don't do any of this designing. I just create it. My artwork and skills are awful. And so a guy on our team designs all of these and then I create them based off of his designs. So I'm not expecting any sort of, I don't grade you based off of your design skills or your artwork skills, if that makes sense. Okay. All right, so that's the scene. Let's go back to our project. If you look at the contents, well, let's go back to hierarchy before we get into this. Your hierarchy shows all of the objects that you have created for that scene. And so when you go from one scene to another, the objects in that scene are going to be different. Okay, so the hierarchy shows what's in the scene, and the project tab shows all of the assets that are in the project. Okay, there's a separation of the two. And so this is where all of your files are. In fact, you can view this. So this, I don't know why this created here. Anyways, this is where this project got created, and all of the files associated with this project are going to be under the assets folder. Okay, and you can see what we see in the project folder matches this specifically. Okay, we have assets and packages. The library and logs and project settings, temps, and user settings, those don't show up inside of Unity because they're not needed here, but that's where it shows up, or that's where it's stored. Assets is here, packages is here, right? Assets are things that you are going to create yourself. So when you download a model, you download textures or animations or any sort of button designs or backgrounds or anything like that, all of it is going to go under your assets. All right. Packages are pre-made things that Unity imports for you. Okay. And so that's what those are. These are pre-existing, pre-made things that you can import into your project, and they are stored under packages. All right. These are specifically from Unity or through the Unity store, whether it's free or not, it'll show up under packages. And so all of the stuff that helps you get started come from here. Okay. All right, so you'll see so far in the scene, there are two things. There's a main camera and a directional light. I'm going to cover super quick basics of both. So first of all, notice I'm in the scene tab. The way you move around the scene tab is this. On your mouse, hold the right mouse button. Okay, you see how when I hold the right mouse button, the eye pops up, and then you see the four little keys next to you. See the icon on the screen change? Shake your head if you see it. Okay. When that happens, you can hold the right mouse button down, and then you can go left and right on the mouse and look. So this opens up the object to use the mouse as a look tool. And you can also go forward, backwards, left, and right with WASD. Okay, this is super helpful. This is how I move around in the environment when I'm doing stuff. So if I want to get down closer, I'll hold the right mouse button and then W, and this allows me to look around and do all sorts of different things. Okay, that's how you move around in the environment. So main camera, you can see the camera's frustum, which is the viewport essentially for what the camera can see. All right. There's also a directional light, and what directional lights are, they shine light in a direction. Pretty basic. You can get more complex or more in depth with these, but it's honestly not necessary. We have a main camera here, and what I'm going to do is I'm going to move over to the main camera, and I'm going to add a couple items. So to add items to your scene, you can do it a couple different ways. You can drag and drop from your assets or from your project tab into your hierarchy tab. You can right click in your hierarchy tab and go create different things, or you can click on this up here and essentially get the same thing. So I'm going to add a plane, and the plane is going to exist in the environment here. You can click here and rename it if you want. I'm going to name this ground. And then let's take a look over here at one of the last tabs that we haven't looked at, which is the inspector tab. The inspector tab holds all of the information about whatever object you have selected. Okay, and so if you select one of these objects here, all of the properties for that object are going to show up under the inspector. If you click on a property or you click on an object from your project tab, any applicable properties for what you have selected is going to show up under the inspectors tab as well. All right, so if we go back over to our sample scene, what I want to do is I want to go to ground and let's take a look at what we have available. Now, Unity is what is called a component-based game engine. What that means is you can add components to objects to modify their behavior. So, first thing, the objects that I keep referring to in Unity are called game objects. It's a generic term that simply refers to any object, and it, like I said, super generic. So cameras, lights, characters, objects in the game, all of those are game objects. And the way Unity works is you can change the way those objects behave or how they interact with other objects by adding or removing components to them. The components will show up over here. So for example, we have a transform component, we have a mesh filter component, a mesh renderer component, a mesh collider component, and then a material component. All right, you can collapse these. You can remove them by clicking on the three dots on the side and go, well, you can't remove the transform. Remove component here if you want to remove them like that. Now, every object, every game object will have a transform component. So if I click on main camera, the main camera has a transform, the directional light has a transform, the ground has a transform. All objects must have a transform component. It's the only component that all objects will have. The transform component itself is broken into position, rotation, and scale. And all of these are float values, meaning they can have decimals. Okay, so let's talk about each of these. Let's go to ground. Position is the physical location for where it exists. If you guys remember last class when we looked at the left-hand rule for representing 3D environments, and we said the thumb was the x-axis, the index finger was the y-axis, and your middle finger, which is pointing forward and backwards, represents the z-axis. That's what we see represented here. All right. So generally speaking, you want your ground at y position 0. Okay. And so when it creates it, it kind of puts it at a weird place. So we want this at position 0. And generally speaking, we want it at 0, 0, 0 to start with. Okay. Now, rotation is, as you can expect, how it's rotated. And you can rotate it along any of the three axes. So this is X rotation. So this is going to rotate it along the X axis. This is Y rotation. That rotates it along the Y axis. And then this is Z axis rotation. It rotates it along the Z axis. All right. Scale is the same thing. You can scale it along any of the axes. So this is X. You can't scale a plane along the y-axis because it by default is a plane. So it's always going to be a thickness of 1 or the z-axis here. So if I want to make it bigger, I could just scale the x and the z by that. Okay. Questions on transform? All right. So as you move objects around in the game, you're going to be messing with the transform a lot. Okay. All right. Now, let's take a look at these other ones. Anytime anything is visible, it's going to have a renderer to it. A renderer is what actually renders it to the screen. It's what makes it visible. All right. And you'll notice some of these components have check marks and some of the components do not have check marks. Ones that have check marks can be disabled or turned off. And so if I want to turn off the renderer, I can unclick it and you'll notice, hey, it went away. Turn it back on by clicking this. Okay. Generally speaking, you won't need to do much with this, but you can control certain aspects like does this cast shadows? Does it, excuse me, receive shadows? And that sort of thing. Again, going over basics like this is tough because some of you are really going to have to mess with this stuff and some of you aren't. And so I want to cover just enough to let you know what exists, but not too much to where if you aren't utilizing this particular aspect, that it's not going to be kind of like a waste of your time for right now. All right, next thing, mesh collider. So colliders are what are responsible for detecting collision between different things. All right, so if you have one object and you want to be able to detect a collision with another object, you need to make sure they have colliders. Generally, and there are lots of different colliders. There's capsule colliders, there's box colliders, there's wheel colliders. Mesh colliders mean whatever the shape of the object is, the collider will mimic that. And so you might think, well, that's perfect. I always want to use mesh colliders. They're really expensive and you want to avoid mesh colliders unless you absolutely have to, because the math and the performance associated with detecting collision is expensive. So the more basic the shape, the less expensive it is to calculate the collision. Okay. Questions so far? All right, so let me make the ground just a little bit bigger. And then I'm gonna create folder, and I'm gonna call this materials. So let's talk a little bit about materials and textures. We'll do a quick introduction to this. I'm also going to create a folder called textures. Now, if you remember before, textures change how characters look. Okay, they change how 3D objects look. And the way Unity has it set up is textures go on materials and materials go on characters, or materials go on objects. And so what I'm going to do is I'm going to create a material. And then I don't know if I can create a texture. Can you create a texture? No. All right. And we'll call this ball material. I'm also going to create a sphere. Okay. And we'll call this our light. Now, so I'm going to click on player. Notice that by default, it has a sphere collider. And what I want to do under the renderer is I'm going to open up this materials tab and I'm going to drag and drop the ball material that we created. Okay. Notice it doesn't change the appearance. Okay. We still have a very plain white ball. So if I click on the ball material, notice it has a few different things. And again, this is a crash course in textures and materials. You guys are going to need to spend some time looking at this on your own, depending on what you're doing for your game. My goal for today is just give you a quick overview, because I am going to give you lots of not only class time, but non-assignment time where you can explore these yourselves. Textures. Textures and maps are interchangeable. Okay, so you can kind of use those terms interchangeably for the most part. And if you look at this on our ball material, we have a series of textures that can be used to fill in these places. Okay, generally speaking, you guys are going to get all of these textures. It's a loud chime. You're going to get all of these textures online through different sources. And so, for example, if I go to Google and I type brick texture Photoshop, sure. Images, and just pick one of these. Sure, this one looks good. Now, when you are picking textures, you generally want to pick them that have the same width and height. All right, so this is 800 by 600. And let me actually download this one and show you kind of what you can do. So I'm going to download this here, go to desktop, What? Well, let me do this. Ah, we outsmarted it. And so you can open this up in Photoshop, you can open up whatever, and you don't. Does it recognize the file type? Let me grab a different one. I'm just going to use this as an example. Okay, so here we have a brick texture. And what a texture is an image. That's all it is. And what's going to happen is this is going to get wrapped around our sphere, or it could get applied to our ground. Either way, it doesn't matter. And oftentimes there are tons and tons of free ones online. I would suggest going through the Unity store because those are going to be specific to 3D objects. This isn't necessarily. What I'm going to do is I'm going to, this is what, 500 by 300. I'm going to do 256 by 256, and we'll just do it like that. We'll call this brick texture. Now, the reason you want it the same width and height is if your object itself is universal, meaning it's a symmetrical shape, you want a symmetrical texture. If you don't have a symmetrical mesh or symmetrical model, then you don't need a symmetrical texture. We do, so that's what we want. And so we're going to go and open up this project. I'm going to go into our textures folder, click show and explore, and drag and drop this brick texture into our textures there. Now it shows up here for brick texture. Now, you'll also notice that I set the resolution to 256 by 256. Why did I pick that? You want your texture resolutions to be power of 2. So 128, 256, 512, 1024, 2048, 4096, and so on. When games talk about, oh, this uses 4K textures, that's what that means. It means the texture resolution is 4096. It just means it has greater detail. Obviously, it comes with a performance cost. In fact, I'm going to rename this ball texture. Okay, so we have our ball material, and we can now assign to our ball material our ball texture. The albedo is the map that's responsible for how it actually looks. So I'm going to drag and drop this right here, and you'll notice all of a sudden we now have a brick ball showing up. It's exactly how it works. All right, I can click this and delete it to make it go away and reassign it there. There are other texture maps. Metallic refers to how shiny it is. You can use these sliders if you want to make it. This kind of mimics that. Same thing for smoothness. If you want to get like a metallic brick, which isn't a thing, you can do it that way. So these slides can be used in place of having a specific metallic texture. Generally speaking, you guys are going to be working with 2 different texture types, and that's albedo. That's literally how it looks. And then there's a normal map. Normal maps are sometimes called bump maps, and they deal with the how bumpy a texture is. So if you, for example, can you see my hand? You see like the ridges where my bones are? That sort of bump would not be represented in an albedo texture. Okay, you would want a bump map to get those sort of bumps there. Okay, that's kind of the difference between the two. And a lot of times they'll come with that, and you would just drag and drop that to the normal map. And those often are shown as they look like a bluish texture. I'll show you an example here. Let me go to so here we have a football player, and if we look here, you can see it set up. This is normally it'll say albedo base. It's the same thing, and then you have a normal map. The normal map looks like this, okay? And it's what actually gives texture to the actual jersey. So if you look in the back here, if I go to upper body and I delete this, watch how it changes the display. Okay, did you see the difference? Okay, so the normal map really gives life and like depth to the actual model. That's the difference. You can see the same thing on the pants, like the ripples and that sort of thing. That's the difference between the two. Okay, we don't need that for what we're doing. Okay, second thing. Now that we have a ball and we have our environments, we'll do a very quick. I'm just open up. Fireworks is like the same thing as Photoshop. I just never learned Photoshop. So we're going to do a very sweet looking grass. Ultra realistic. What? Why can't I see this? I want something larger. This is dirt. You can tell because it looks exactly like dirt. All right, so we'll save this to the desktop and then we'll pull it in this way. All right, so materials, I'm going to create material, we'll call this ground material. Click on the ground, come over here under materials, drag and drop right here, and then click on ground material and assign the texture. And then we get that. Blown away by the ultra realism that we see here. Okay. Questions so far? I want to try to get to scripts before class is over. All right, so can you tile the texture? Yes, you can tile the texture. If you go to the ground or you go to any of the materials right here, tiling, if you want to double it, you just, instead of one, you put two. Why is it not tiling? Oh, problem. You can tile it by increasing the number here. So we'll go 5 and 5, just like that. Now we have small dirt. All right, next thing, scripting. We're creating a folder for scripts. Now, scripts in Unity function as components. So we talked before about we have the ground, we have the player. We can control the way they behave by adding components to them. Scripts are components. So I'm going to right click, create C# script, and we'll call this player manager. Okay. And then I'm going to open this up. So Visual Studio is the editor, the IDE that you'll use for this. And I say this is good. Here's what you get. All new scripts in Unity start like this. They're going to start with a start function and an update function. Basic C# stuff. So if you haven't seen C# before, it's nearly identical to Java. Slight differences in syntax, but most of it's the same. All right, so don't be freaked out if you've never seen C# before. It's very, very simple. So here's our class, player manager, like Java. It's got to match the file name. And one slight syntax variation is inheritance. All scripts by default in Unity will inherit from this class called monobehavior. Okay, and in Java, to show inheritance, you would do extends, I think. You would say public class player manager extends monobehavior. In C#, you simply use a colon. That's it. All right, so this means player manager inherits from monobehavior, and monobehavior is where these functions exist. Okay, that's why we can call them. So start is called as soon as the object is loaded. Right, so right when the game starts up, the object gets loaded, start gets called, it only gets called once. Update gets called every frame. Okay, that's the difference. All right, so we're going to do a very basic player movement script. So I'm going to say private float player speed. And in start, I'm going to initialize it to be 5. Now, why did I put an F here at the end? Float is the floating point data type in C#. So instead of double, where you use double in Java, you'll use float here. And whenever you specify the value, you have to put an F at the end. It's just how it works. Okay, so we'll say player speed is 5. Now we'll come down here in update, and what we want to do here is we want to move the player. And there's lots of different ways to move the player. I'm going to show you one way to do it, and that is by moving the player's position. Okay, you can do physics-based movement in Unity. It has a really good physics engine in it. And if you want your objects to use physics, you simply have to add the rigid body component to it. There's lots of super great intro tutorials on how to do that. I'm going to do it a different way. One is not better or worse. This is just how it works. Okay. So here's how we're going to do this. In order to move the player, effectively what I'm going to do is move its position. Okay. And so if we look right here, we see the position of the selected player. And if I take this and I slowly increase the Z value, notice how he's moving. Okay. And so we are going to simulate that same thing in code. All right. In fact, what I want to do is I'm going to move this back a little bit to start. Let's move him back to here. Okay. So we'll start him at -10. So I need to get access to this transform component because I need the position property of the transform component, because that's what we're going to change. So let me go back to our code, and I need to get access to that transform property. So here's what I'm going to do. I'm going to say public transform player transform. Okay. Now, a couple things. When you make something public, it will show up in the inspector. This is the inspector right here, and allow you to specify that property. So the first thing that I'm going to do is I'm going to select the player in the hierarchy, and you'll notice this is the list of components that we have on the player. I need to attach the script as a component. So I can go to add, I could go add component, go down to scripts, and find player manager and add it like that. Or remove it. You can simply drag and drop here as well, and it adds it. Good so far? So now this script is attached to the player game object. And when the player gets loaded in the hierarchy, the start function of this is going to run. You'll also notice that we have a player transform pop up here, and we specified that here. Okay. If I change this to private, meaning I can only see it inside of this class, it's going to disappear from here. Right. So we don't have access to that. Generally, the best thing to do is either to make it public, or you can do this serialized field next to it here. And what that will do is allow it to show up here as well, but keep it private. Okay. For what you're doing, it's fine to make it public. So here's how we're going to do that. We need to assign the player's transform inside of this script so that we can have access to it. So I'm going to, with the player selected, drag and drop the player game object into this space here. When I do that, it's going to automatically find the transform component and assign it here. It's smart enough to do that, which is super helpful. So now that we have it linked, I can use this player transform variable to access the transform component that's on the player. Okay, so inside of update, I can say player transform dot, and then we have three things that we can mess with here. We can mess with, sorry, wrong thing. We can mess with the position, the rotation, and the scale. All right. So back here, we can say player transform dot position equals, and then we can change it. All right. So here's what we're going to do. Let me come up here first. Position, rotation, and scale are represented as a type called vector 3. All right, so we're going to say vector 3. I think the easiest way to do this. Well, we'll go like this first. Okay, so position, if I mouse over this, notice how it pops up that it's a vector 3. A vector 3 has 3 components, X, Y, and a Z. That's why it's called vector 3. And so each of those individual properties, X, Y, and Z, are represented as float values. And so if I wanted to set the player's position, let's do it like this first before update. When the game starts, I'm going to say player transform dot position equals new vector 3, 0 for X, 0 for Y, and 0 for Z. Okay, we save that and come back here. Now, where is the player right now? He's at 0x, 0.5y, and -10z. So when I run this, we expect him to move to the exact center. So I'm going to click play to run this. Let me unmaximize this and look at it from the scene view. Okay, so this is why some people like to separate it. Let me turn it from. When I click play, we see this pop right to the middle. Stop. Hold on. Go to your game scene, uncheck maximize on play if you don't want that to happen. So we'll see him pop to the center. All right, and he's doing that because this line of code is running. All right, good so far? All right, let me go back to this. So if I wanted to say, we'll say private float, we'll call this normal height, and we'll set normal height equal to 0.5 f. And we do 0.5 because that's when the player's like resting on the ground. We don't want to set it to 0 because if we do 0, he's in the ground halfway. So we'll set it to 0.5. Okay. Then we can do like this. So set his position to 0, normal height 0. We go back here and we run it. And now he moves to the middle, but he's actually sitting on top. Hold on, let me look at chat. Yes, so you have to, in your project settings, go edit project settings. Nope, wrong window. Hold on, this is wrong code. You'll want to specify your editor as Visual Studio. Where is it? It's been so long since I've done this. Player. Is it player? Is it player? They move these around so often. Maybe we're in project setting. Maybe it's in preferences. Here it is. It's in preferences, external tools, the external script editor. You'll want to select it here. That's probably why it's not showing up. You can do that. Okay. All right, I wanted to try to finish up with this before we run out of time. So I'm going to leave this at 10 F. All right, so we could move him to way up in the air, way over here, and when the game starts, he gets plopped back to his start position. I would suggest using Visual Studio. I don't know if you can use any other ones. You can use other ones, yes, but unless you have a really good reason for it, use Visual Studio. It's good. Okay. All right, so back in here, what I'm going to do now is I'm going to come down here and update. Remember, update runs every frame. So if your game's running 60 frames a second, it's going to run this code 60 times every second, which is a lot. So we're going to say current Z, and I'm going to set this equal to player transform.position.z. So we're going to get access to the current Z value. So the very first time this runs, we're going to get -10 because that's where it is starting based on the code that we put up here. Okay, so we'll get access to its current Z position. And what I'm going to do is I'm going to move it forward slowly. Okay, so I'm going to take this player speed and I'm going to set it to something smaller like 0.2. Okay. Now we'll say player, I can spell, player transform dot position equals new vector 3. We'll keep the current. Well, we can do it like this. We'll say current x1. Thank you. Yeah, we'll keep the current x because x first, y in the middle. For y, I'm going to call normal height because we don't want to move the player up and down. And then I'm going to say current Z plus player speed. Okay, good so far. So we'll keep the current X. We won't move his X. We'll keep his current Y, and we'll move him forward, which is the current Z plus this player speed. Good. Save, run. Off he goes. Cool. All right, last thing we'll do is instead of having this happen automatically, let's have it go off of user pressing button. The way we do that is, again, you'll want to look into different input systems for Unity. We'll use the built-in one, which is certainly functional. We'll say if input dot get key and get key down. These are two different ones. Get key runs continuously. So as the user holds the key down, this is going to continue to run. Get key down only returns the very first frame that the user pressed the key. So if you want them to be able to hold down a button and have them move, you're going to want to use get key. All right, so get key, key code dot, is there an up arrow? Up arrow. Okay. And so we will do this. So now when we run this, he's going to stay still and not until I press the up key is he going to move. Okay. We can do the same thing with the if input dot get key code dot left arrow player transform dot position equals new vector 3 current x minus player speed normal height and then current z. So now we can go forward and left. We can't go right because it's not there. And our player's moving really fast. Let's slow him down a little bit. Let's go 0.05. Any questions on this? Okay. All right. Well, let's we'll stop here because you guys get the basic idea. Again, I wanted to show you kind of the basics of Unity, the whole idea of creating scripts, attaching them. Can I answer any specific questions right now? Okay. All right. Well, we will stop here for today. Next class, we'll work a little bit with this. We'll also go over some representing some objects in 3D space and moving them around and that sort of thing. But we'll get to that a little bit later. Yeah, that's all I got for you today. Have a wonderful day. I will see you on Thursday.
Thank you.
You're welcome.
Professor.
Thank
If
you.
do,
See you
you're
Thursday.
welcome. If
Thank
you do
you.
have questions, feel free to stick around.
Thank you.
Thank you.
You're welcome.
Hello, can you hear me, Professor?
Uh-huh.
So, I was wondering since we're supposed to do a 3D game, I was wondering if we could do it as a VR game,
Yeah, that's
like
totally
a
fine.
basic. Okay, cool. Because I'm kind of going for VR development as for my profession, so I figured it might be good to make, not obviously get too complex, but make something basic such as that. But would it be
Yep.
fine if if there was a change from VR to 3D, if it does end up not seeming as realistic for it to be a change to the game design document, or no?
Yeah, and that's fine, because really the only thing you're changing is how the camera operates. The game itself is the same. The controls will be a little bit different with VR, but the main environment of the game is going to be the same. So that's totally fine.
Okay, thanks, Professor. Have a good
You're
day.
great. You too. All right, I'll see you guys.